Hey guys, Jim here. Welcome back to our SPI Ultrasound Physics Registry review. Feel free to pause the video after I ask the question, give you enough time to answer it before I answer it. Let's dive right into this thing. Question 1. Click on the slice thickness artifact. The answer is right in this region here. So all of this at the bottom of the bladder is a slice thickness artifact. Question 2. What type of artifact are the arrows pointing to? A. Focal banding. B. Focal enhancement. C. Grading lobe. Or D. Reverberation. The answer is C. Grading lobe. Question 3. What type of artifact is the arrow pointing to? A. Slice thickness. B. Beam width. C. Side lobe. Or D. Reverberation. The answer is A. Slice thickness. Question number 4. How do you make the line on the left look like the line on the right? A. Increase PRF. B. Lower frequency. C. Increase the angle. Or D. Decrease the wall filter. So how do we make this line look like this line? The answer is D. Decrease the wall filter, because there's no color Doppler in this line where it's full in this line. So all we have to do is decrease the wall filter or PRF, Nyquist limit, or the scale to make the color fill in this line. Question number 5. Which transducer produces a wedge-shaped sector? A. Sequential. B. Convex. C. Linear. Or D. Vector. The answer is D. Vector. Question number 6. What are the benefits of this probe? A. 1.5D array imaging. B. Superficial imaging. C. 3D 4D images. Or D. Extended field of view. The answer is C. 3D 4D images. An annular phased array uses what to steer the beam? A. Discs. B. Rings. C. Motor. Or D. It's electronically steered. The answer is C. Motor. What is inertia and what does it describe? A. Energy in a system never changes, but may change to a different form that describes attenuation. B. Flow is equal to the difference in pressure in a vessel that describes resistance and flow. C. Increase in velocity must be accompanied by a corresponding decrease in pressure that describes stenotic flow. Or is it D, an object in motion stays in motion until acted upon an external force and describes the density of a media? The answer is D. An object in motion stays in motion until acted upon an external force and describes the density of a media. Question number 11. Which is not true about this probe? A. Better spatial resolution across the sector. B. Extended field of view throughout the sector. C. Greater transverse resolution in the far field. Or D. Small footprint. This is called an endocavity probe, which has a small footprint here, and this provides better spatial resolution all throughout the sector, as well as an extended field of view, but it does not create greater transverse resolution in the far field. Transverse resolution is also known as lateral resolution. Question number 12. Which of the following best describes 10 crystals firing at the same time, followed by another set of 10 crystals firing at the same time, followed by another 10 crystals firing at the same time? A. Phased, B. Sequential, C. Sequestered, or D. Mechanical? The answer is B. Sequential. Question number 13. What type of artifact is this? A. Slice thickness, B. Beam width, C. Side lobe, or D. Reverberation? So what type of artifact is this right here? The answer is C. Side lobe. Question number 14. Which transducer produced this type of sector? A. Linear, B. Convex, C. Phased, or D. Vector? The answer is D. Vector. A vector transducer will produce a flat top sector. Question 15. What happened to make the top waveform look like the bottom waveform? A. Frequency increased, B. Thick PZT crystal, C. Thin matching material, or D. Speed increased? So what happened to make this waveform look like this waveform? It looks like the frequency of this sound wave decreased compared to this one. That would mean that this transducer has a thick PZT crystal. The thicker the crystal, the lower the frequency, and vice versa. So the thinner the crystal, the higher the frequency. Question number 16. Which is not associated with a thick PCT? A. Low frequency, B. Slower speeds, C. Long wavelengths, or D. Better axial resolution? The answer is D. Better axial resolution. Axial resolution doesn't really improve with a thick crystal because that means you have a lower frequency. However, if you have a thinner crystal, this will increase your axial resolution because you'll have a higher frequency. Question number 17. A mechanical transducer uses what to steer the beam? A. Motor, B. Rings, C. Mirror, or D. It's not steered? The answer is A. Motor. Question number 18. Which has the widest field of view in the near field? A. Linear, B. Vector, C. Sector, or D. Curved? The answer is D. Curved. Now, what if this question said, which has the narrowest field of view in the near field? And the answer to that would be sector. A sector will start at a point and will diverge from there, thus making it really narrow in the near field. Question number 19. What does the spectral waveform demonstrate? A. Ranged ambiguity, B. Spectral mirror, C. Spectral broadening, or D. Slice thickness? This spectral waveform closely resembles a spectral mirror artifact. However, the spectral mirror has to be directly below the above spectral waveform. In a typical spectral mirror artifact, this should be right over here in the same region where this takes off and goes above the baseline. So this should be over here. These waveforms here should be shifted over a little bit in order to count for a spectral mirror. And we know this is not spectral broadening because there's a spectral window in each waveform. And this isn't a slice thickness artifact, but this is a range ambiguity artifact because this is a waveform coming into view on this spectral waveform from a different angle. What's happening is the continuous wave Doppler is picking up different frequencies from different areas of the body and incorporating it into this image. This is called range ambiguity. Question 20. What type of artifact is this? A. Range ambiguity, B. Side lobe, C. Slice thickness, or D. Beam width? The answer is D. Beam width. Question 21. Which is not associated with wide bandwidth? A. Low quality factor, B. Backing material, C. More sensitive, or D. Multi-hertz? The answer is C. More sensitive. When you have a wide bandwidth, that means it's going to be less sensitive to convert low-level frequency Doppler shifts into meaningful electrical signals. Question 22. Which type of transducer will create this type of pattern? A. Vector, B. Curvilinear, C. Phased, or D. Sequential? The answer is D, sequential. So if you look over here at this diagram, each little red rectangle represents a crystal. There are 5 crystals here that are firing at the same time, followed by another 5 set of crystals, which is followed by another set of 5 crystals, so on and so forth. This is called a sequential pattern. Question 23. Which transducer produced this type of sector? A, concave, B, vector, C, curvilinear, or D, phased? The answer is C, curvilinear, hence the blunted sector. Question 24. How do you fix this image? A, increase gain, B, decrease suppression, C, increase compensation, or D, decrease compression? The answer is B, decrease suppression. Suppression is a synonym for reject and threshold. So what's going on in this image is the reject is turned up, thus suppressing the low-level frequencies in the chambers here, but it's decreasing our detail in the myocardium throughout the heart. Question 25. What happened to make the line on the right look like the line on the left? A, PRF decreased, B, wall filter increased, C, packets decreased, or D, angle increased? So what happened to make this line here look like this line? So what's happening here is the wall filter is increased, thus eliminating the low-level frequency Doppler shifts and making the vessel clear or void of color. What type of artifact is the arrow pointing to? A, beam width, B, slice thickness, C, side lobe, or D, reverberation? The answer is A, beam width. How do you make the line on the right look like the line on the left? A, increase wall filter, B, increase color gain, C, decrease PRF, or D, decrease volume gate? So what do you do to make this line here look like this line here? So if you haven't figured out by now, these are 2 vessels. One is filled with color, while the other one is void of color. A vessel void of color that is not obstructed is caused when either your Nyquist limit, your scale, your PRF or your pulse repetition frequency, and or your wall filter is turned too high. Once you decrease these factors, then you'll start to see more color in your vessel. So the answer is decrease your PRF. And that concludes all the questions for this test. I'll hurry and write 25 more questions and upload that video as fast as I can. If any of you have any questions about your upcoming SPI boards, feel free to email me at ultrasoundboardreview@gmail.com, or you can personally text or call at 435-922-1635. If any of you are looking for mock exams, feel free to subscribe to our mock exams on our website, ultrasoundboardreview.com, or if you're looking for more of a one-on-one SPI tutoring, you can subscribe to our SPI tutoring on our website as well. I'm Jim with ultrasoundboardreview.com. We'll see you next time.